Hi, and welcome to Section 5, Introduction to Physics. In this section, we will look at game physics using the Unity game engine. This is not a physics course, rather a section dedicated to game physics in Unity 5. We will start with a look at several basic concepts and move on to more advanced physics concepts. Now we move on to the first video of this section. This is an overview of Unity physics. By the end of this video, you will have a good appreciation for what game physics are and how they are employed in Unity 5. In this video, we're going to start with an answer to the question of what is game physics. You'll find this enlightening even if you have developed games before. We will then discuss what physics look like in a game, and finally, we will cover several terms and concepts important for our understanding of physics in Unity. We can define game physics as how the laws of physics are replicated during gameplay. Let's take a quick look at those laws. The law of universal gravity states that an object attracts another object in direct proportion to their combined mass and inversely related to the square of the distance between them. There are three laws of motion that define the relationship between an object's acceleration and the forces that act upon it. The first law is that an object remains at rest or in a uniform state of motion unless that state is changed by an external force. The second law is that force is equal to the change in momentum over time. In other words, the rate of change is directly proportional to the amount of force applied. The third law is that for every action in nature, there is an equal and opposite reaction. Physics also includes thermodynamics laws and electrostatic laws. Two principles are also relevant to our discussion of game physics. The principle of relativity states that laws of physics are the same for all inertial reference frames. The principle of constancy of the speed of light states that light always propagates through a vacuum at a definite velocity, which is independent of the state of motion of the emitting body. So game physics is a replication or simulation of real-world physics in a 3D game. Fortunately for us, the Unity game engine completely understands physics, so we do not need to be experts. The Pong game is often referred to when discussing early game graphics. This game, from the early 1970s, had crude graphics but aptly demonstrated basic physics. The ball would travel at a constant speed and direction until acted upon by external forces, in this case, the player's paddle. Game physics are a core component of modern games. We can see this when we fire a weapon. The projectile travels as you would expect a real-world projectile to travel. It has decreasing speed and velocity, and its course can change depending on external forces. Physics represents one of the visually enjoyable components in games. Blowing things up in a game world can be great fun. We love explosions, kicking in doors, breaking windows. Game players, and to a lesser extent game developers, take game physics for granted. We are accustomed to our game engine doing all the complex mathematical computations and at a staggering computational rate. There are several terms and related concepts that we should be familiar with when implementing physics in Unity. Let's look at these briefly. Colliders are game objects that are used to make impact. Colliders collide with other colliders. We will look at colliders in great detail in a later video. We can enable or disable a collider as a trigger. This allows us to detect when a collision has occurred. Rigid bodies allow us to add mass to a body to replicate real-world gravity and the effects of other forces. A physics material in Unity is a type of asset that provides information regarding how one object reacts to another. In Unity, we can use three different types of physics joints to create a rigid body. These are fixed, hinged, and spring. Force and torque are not unique or specific to Unity, but important nonetheless.